This is a step-by-step video demonstration of the lightweight Python-based malware analysis pipeline. There are two bash terminals open. The upper terminal shows the output of the lightweight Python-based malware analysis pipeline, and the lower terminal illustrates the Python-rich malware analysis pipeline framework. The Python-rich malware analysis pipeline framework displays the statistics of Joebox and Triage and lists all analyzed samples with task IDs, sample name, and the plugin progress. We start it with pip env and see that no sample is listed in Python-rich malware analysis pipeline framework before the main program with its plugins is loaded. The main.py controls the lightweight Python-based malware analysis pipeline. It generates new task IDs, imports utilities, and loads the environment, which calls the abstract plugin to iterate through all the defined plugins of the config file. The main.py is loaded with pipenv as well. The email plugin parses all incoming emails from the spam traps. Every email contains information in the header and body, which helps to correlate the attributes in MISP. The information and correlation in MISP can be used to identify different threat actors and their TDPs. Subject from, received from, and attachment name is written to a newly created JSON file. In the upper terminal, we can see that the email plugin has found a new email with a zip attachment and created a new analysis directory. In the lower terminal, the sample name is in this step unknown, as the name of a potential malware sample will be known at the end of this plugin run. The task ID and progress are set to 1 as this is the first plugin. The Unpack plugin checks if the extracted attachments of the email plugin are archive files. If this is true, the archives are decompressed. It is also possible that the executable was directly attached and not compressed. In this case, the executable itself is used for further processing. The executables are then uploaded to the sandboxes in the following plugins. The Unpack plugin has extracted one executable from the archive file, which we can see in the upper terminal. The lower terminal shows that the sample name in the illustrated figure has been updated to paymentconfirmation.zip, meaning the email has an attachment with this name. At the end of the plugin run, the name will change to the sample name of the decompressed file. The progress bar has been updated to 2 of 9. If the analyzed email has an attached binary in combination with the Unpack plugin, the sample is uploaded to Joe Sandbox, which is the case in this demonstration. The sample is analyzed in a cloud-based virtual machine, and Joe Sandbox tries to reveal the malicious activities of the sample. Joe Sandbox produces multiple report formats. Only the JSON report is downloaded and parsed. If available, the malware signatures and C2 configs are stored in a newly created JSON file. In addition, all memory dumps, PCAPs, and available binaries will be stored on the analysis server. This information will be analyzed in the following steps by the Yara and PCAP plugins. The parsing of the JSON report is very important, as the extracted data is used in the MISP plugin to create MISP events with the sandbox IOCs automatically. The upper terminal shows Joe Sandbox has detected the malware signature agent Tesla and could extract the C2 config with the exfiltrating email address and server. The lower terminal shows the sample name, which has been updated to paymentconfirmation.exe. The progress bar has changed to 3 of 9. Emails with attached binaries or binaries and archive files are uploaded to the Triage Sandbox as well. The Triage Sandbox runs the sample in a cloud-based virtual machine and tries to reveal the malicious activities of the sample. Triage Sandbox creates multiple report formats. Only the JSON report is downloaded and parsed, and the malware signatures and C2 configs are stored in a JSON file, if available. Furthermore, all memory dumps and PCAPs will be stored on the analysis server. This information will be analyzed in the following steps by the Yara and PCAP plugins. The parsing of the triage report is essential, as the MISP plugin uses the information to create new MISP events and attributes. The upper terminal shows that Triage has detected the malware signature agent Tesla and could extract the C2 config with the exfiltrating email address and server. The task ID and sample name stay the same in this step, as you can see in the lower terminal. Only the progress bar has been updated to 4 of 9. Yara scans all memory dumps and binaries of the sandbox runs and saves the output in a JSON file. The freely available rule set of Malpedia from the German Fraunhofer Institute is used for this scan. Only TLP clear and TLP green Yara rules are used. The upper terminal shows that the analyzed sample has multiple agent Tesla hits in Joebox and one agent Tesla hit in Triage. As you can see in the lower terminal, the task ID and sample name stay the same in this step. Only the progress bar has been updated to 5 of 9. Suricata is a network analysis and threat detection tool. It can scan PCAPs with a specific rule set to find malicious network traffic. There are multiple high-value rule sets on the market for free. The rule sets from abuse.ch and Proofpoint are used in this demonstration, containing over 100,000 rules. The upper terminal shows that Suricata has found one agent Tesla exfiltration network connection via SMTP. As you can see in the lower terminal, the task ID and sample name stay the same in this step. Only the progress bar has been updated to 6 of 9. All executables tagged with a malware signature by at least one of the 2 sandboxes are uploaded to MalwareBazaar. Samples not yet known to MalwareBazaar are reported anonymously. The upper terminal shows that in this demonstration, the sample has been reported to MalwareBazaar, as the signature from Joebox and Triage was Agent Tesla, which will be visible in the Statistics plugin. As you can see in the lower terminal, the task ID and sample name stay the same in this step. Only the progress bar has been updated to 7 of 9. The Statistics plugin parses the reports of the different sandboxes and updates the statistics JSON files of each sandbox if there is a malware signature available. The top 4 malware signatures of the sandbox overall statistics are listed in the tables Joebox, Stats, and Triage Stats for demonstration purposes. The upper terminal shows that both JSON statistics have listed Agent Tesla as a malware signature. During this plugin step, the Agent Tesla stats in the lower terminal have changed to 1 in both sandbox tables. The task ID and sample name stay the same, and the progress bar has been updated to 8 out of 9. The MISP plugin is one of the essential plugins as it reads all the generated JSON files of the other plugins to create a MISP event with its attributes. After the event creation, all the relevant attributes are added to the event, which MISP automatically correlates. The correlation allows the MISP users to see if specific attributes were already used in other malspam waves of the same malware family or even from another malware family, showing that certain threat actors share their infrastructure. The upper terminal shows that the MISP plugin has created a MISP event in this demonstration with the attributes from the email plugin and the sandbox plugins. The task ID and sample name stay the same, and the progress bar has been updated to 9 of 9, as you can see in the lower terminal. We now switch to the browser to have a look at the newly created MISP event. The malware signature, the date, and the subject of the malspam email were used for the event info. There were 4 tags added: TLP green for sharing purposes, crimeware, as Agent Tesla is crimeware, EXE to give information about the malware sample, and Agent Tesla, which was the malware signature output of the sandboxes. In addition to the event, there were many attributes gained by the different plugins. The email subject, the email source display, the IP source, and the email attachment name are from the email plugin. Both the email destination and the host name are from the C2 extraction of the sandboxes. In this case, Agent Tesla used email exfiltration as a C2 channel. Last but not least, the executable was also uploaded to MISP as well. After creating the MISP event and adding all attributes, the MISP event was published with the cybersecurity community. All connected MISP instances now have access to the shared threat intel information, and the users can now do threat hunting and detection in their network. This is the last step of the lightweight Python-based malware analysis pipeline. The progress in the lower terminal has changed to done, and the main.py will continue to load the next email and generate a task ID 2 for the next sample run. This is the end of the video demonstration. Thank you for watching.